Hello and welcome to this eCognition Deconstructed video. Today we're gonna have a look at the Hillshade Calculation algorithm. What does it do? It visualizes shaded areas from a specific illumination source that you can define. The input elevation layer is just one grayscale layer, DTM or DSM. So what you can define is the azimuth, for example, which defines the direction of the light shining on the elevation raster in degrees. And this is measured from north in clockwise degrees from 0 to 360. And so if you want to have the sun shining from east, you would need to set this one to 90. The default setting is 315, but you can change that at any time. Next one is the altitude of the light above the horizon in degrees. So 90 would be directly from above and 0 would be on the horizon. I think by default it's set to 45 degrees. And then the C factor for vertical exaggeration of the height of the output. So this can be helpful if you want to adjust the vertical units. So for example, if you have a difference in horizontal coordinate units compared to the input surface, by default it's set to 1, but if you need to change that, you can adjust the C value. Why would you want to calculate the hillshade, for example? Most of the time it is done to visualize the terrain, right? It really helps you to see valleys and ridges and the geomorphology that is in front of you, especially if you compare it to a DSM or DTM. The hillshade, as you see on the right hand side, really reveals a more intuitive rendering of the Earth's surface compared to the DSM or DTM. You also can use it for land component mapping. That could be a valuable input. And also for land cover mapping, that's something I have just heard of when I did research for the hillshade here. It has been used, for instance, to help fix confusion between shadows and water bodies. If you try to mimic the sun angle of the RGB image or whatever you have in the hillshade, then you actually can use the information of the shadow that you see in the hillshade to overcome misclassifications for water. Sometimes you do have shadow areas classified as water, but if it's a shadow in the hillshade, it is probably not water. It belongs probably to a tree or to a small rock or whatever. Yeah, that's an interesting approach how you can use the hillshade to improve your classification actually. There are probably more use cases, let me know. But actually for me, before doing this video, the only way I used hillshades were for visualizing the terrain, and that really helped me to understand what is going on the ground. But yep, as you see here, we do have more use cases, and there are probably hundreds more out there. Let's have a look at the hillshade calculation in eCognition Developer. So I am currently in the Rooster development layout, and I'm simply going to drag and drop the T1 elevation DEM TIFF file into the developer, and that's what you see. So grayscale image, dark means low values in the elevation 486 here. White means high values, and in this case that's elevation, so that's the ridge here, and it goes downhill into that direction and also downhill where it becomes less bright, right? Let's instantly choose the hillshade calculation algorithm, and I'm going to leave the default settings here. Input layer needs to be adjusted, that's our layer 1, and the output is going to be hillshade, and that's it. It's going to create a temporary layer here in the view settings, and I'm going to split the view quickly and display the hillshade at the bottom, and you see that visually it's way easier to interpret than the DEM. And you see a lot of small details in the hillshade that that I do not see in the elevation model, like these rivers, the river structures here. Also this one here on the right hand side. So it's actually, this is side by side view. And also on top here, those edges, slopes and stuff like that. It's just not visible in the DM, and it becomes really obvious here if you compute the hillshade. Let's go in here and change, for example, the altitude. That's the elevation of the sun. If you decrease that to 10, then the sun is almost at the horizon, which means the shadow areas become larger. You see it here. Overall, the image is darker. It's just because the sun is at the horizon. Let's go to 80. That means the sun is almost right, or shines from above almost, and you see we get less shadow areas, but the rivers are, or the riverbeds are nicely visible. I'm gonna go back to the default settings, and now the azimuth, let's change that to 0, which means the sun is shining from north, and the shadows should be in south direction, and that's how it is. If you change that to 180, that's just the opposite direction. The sun is coming or shining from south, and the shadow should be on the north face of the mountains. All right, that looks good. What else? Yeah, the C factor. If you have a different elevation unit compared to the X and Y, then you should use the C factor to account for that. Okay, I'm gonna close this one and load the hillshade that I've computed already into a project. Here it is. That's the default setting based on the digital elevation model. And we do have an RGB image that I'm loading here. Let's have a look at the RGB first without the hillshade. So that's the RGB composite. It looks quite foresty. And now let's overlay it with our hillshade, which is layer 1. So I'm displaying layer 1 in the red, green and blue channel, and then you should have an overlay. And now that's a nice combination of the optical data and the hillshade that was produced in the previous project. Okay, last but not least is a cool feature. So actually it also works on other planets. That's an elevation model from Mars, and if you compute the hillshade here, it actually also helps you to understand the surface better, or to improve the visual interpretation. So this is the digital surface model, and let's go for the hillshade, and that looks amazing. So again, that's the elevation data set, and this is the hillshade. And we also can try to combine it, so that's a combination view of elevation and hillshade, and that just looks really cool. So works on different planets, which is a nice feature. Alright, so this is the end of this video. We had a look at the hillshade calculation algorithm. Try it out yourself and see how nicely it reveals the surface characteristics of your elevation models. And yeah, let us know what you think. Have a great day and goodbye.